Good morning. I conjured up a little recursive proof of these two explicit formulas for the sum from k equals 1 to n of k squared and the sum from k equals 1 to n of k cubed. Those don't look altogether obvious or anything like that. So what I did was a recursive proof. What that means is that I proved that it works for the first case when k equals 1, which is real easy. You just only have the sum from 1 to 1, when n equals 1, I should say, the sum from 1 to 1 of k squared, which would be just k squared plus nothing else, and which would just be 1 squared plus nothing else, which would be just 1, or in this case would be 1 cubed and nothing else, which still is just 1, and prove that that can be written as either 1 times 2 times 2 plus 1, 3. So 1 times 2 times 3, 6 over 6. Hey, that worked. It's 1. Or in this case, we would have 1 times 2 over 2, which is still 1, squared, which again is still 1. So yes, it worked in both of those cases. Here's the actual work that I did. Showed, yep, it worked for the first case. And now for a recursive proof, what you do is you assume that it worked for the previous step. So I'm going to say when uh, n was n minus 1, and show that it works for the next one. So here I wrote, all right, here, we're looking for the sum from k equals 1 to n of k squared. And really, that's related to the previous step because it's just n squared more. All the other steps would be exactly the same. So since we're assuming it worked for this, we can rewrite that step like this. And so I did a little simplifying, found myself a common denominator, added things in, and refactored it. And when I did, I found that if it worked for the previous step, the next step can also be written as n times n plus 1 times 2n plus 1 over 6. And since we know it works when k equals 1, well, if it works for k equals 1, it works for k equals 2. If it works for n equals 1, it works for n equals 2. If it works for n equals 2, we know it works for the next step, n equals 3. If it works for n equals 3, it works for the next step, and so on. I also did it for the k cubed one. Run you through that real quick. Obviously, it works when n equals 1. I wrote out the generic nth term like this. I originally, you can see, was putting in the wrong common denominator of 2 before I realized, oh wait, we're squaring that thing. So I changed it real quickly to 4. I squared it out. I added in that other one with the common denominator. I refactored it and never put in my last step. So let's do that right now, where we got to here and realized, oh, it's just that squared. So yep, that works as well. All right, guys, that's it for this short video. I'll catch you next time.